Hello and welcome to video 7 for our Honors Pre-Algebra Blended course. This video is going to go over the answers for the Algebra Extension PDF that I posted next to Lesson 1.6 on the wiki. And this worksheet was taken from an algebra textbook just to help you with your writing of algebraic expressions and numerical expressions. So in your notebook, go ahead and make the heading of Algebra Extension Problems and then work those problems from the worksheet out in your notebook, and then watch this video to see how well you did. So for number 1, it's a solar system question, and it says it takes Earth about 365 days to orbit the sun, and Uranus about 85 times as long, and is asking for a numerical expression. And remember, numerical expressions contain numbers and an operation like times, division, addition, or subtraction. And in algebra, we're actually not going to use the x anymore for multiplication because it's a variable, so we'll use a dot or maybe an asterisk or maybe parentheses around a number to show multiplication. And even division, really don't use that symbol anymore, or your traditional box. Usually division will be shown as a fraction bar. So let's say 5/8. Another way to say 5/8 is 5 divided by 8. So a little tangent there on that one, but in this particular problem it says it takes 85 times as long. So what we're going to do is we're going to take 85 times 365. That's a numerical expression because it has numbers and it has an operation. You could have written it as 85 asterisk 365, or you could have also done 85 parentheses 365. Any of those would work for number 1. For number 2, we have there are 1024 bytes in a kilobyte. Write an expression that describes the number of bytes in a computer chip with n kilobytes. So this is going to be an algebraic expression because it has a variable n, and there are 1024 bytes in a kilobyte. So we're going to take 1024 times n, the number of kilobytes, to get the number of bytes. So the answer to number 2 would be 1024n. That would be the best answer. If you wrote 1024 asterisk n, that's okay, or 1024.n, that's okay. This is actually probably the best way to write that. For number 3, we have a theater problem. H. Howard Hughes, Professor Emeritus of Texas Wesleyan College, and his wife, Erin Connor Hughes, attended a record 6,136 theatrical shows. Write an expression for the average number of shows they attended per year if they accumulated the record over y years. So again, they're giving us the variable y, which means we're going to write an algebraic expression. And remember, I told you that division now, we're not going to use that division symbol. So if you wrote down 6,136 divided by y, that would be okay. But the way we're going to write that in algebra is 6,136 divided by y. We'll write that as a fraction. Okay, so that's your best answer for number 3. Let me go ahead and erase what I have here, and we'll go on to number 4. So tides. The difference between the high and low tides along the Maine coast in November is 19 feet on Monday and X feet on Tuesday. Write an expression to show the average rise and fall of the tide for Monday and Tuesday. So we have, let's see here, number 4. 19 feet on Monday, that's Monday, and we have X feet on Tuesday, and it says write an expression to show the average rise and fall of the tide for Monday and Tuesday. So what we'd want to do to find the average of those two is add them together. and then divide by 2. For number 5, we have a toy manufacturer producing a set of blocks that can be used by children to build play structures, and the product packaging team is analyzing different arrangements for packaging their blocks. One idea they have is to arrange the blocks in a shape of a cube with B blocks along one edge. So for number 5, we have this cube design that looks something like this, and it's B, B, and B. And so I don't know how many levels there are, but if you kind of visualize these blocks going this way, stacked that way, and then also stacked high here, okay? But they're saying that the same number of blocks would be on the bottom, the width, and the height. So for letter A, when it says write an expression representing the total number of blocks packaged in a cube, measuring B blocks on one edge, that would simply mean B times B times B, and the best way to write that would be B cubed. For letter B, it says the packaging team just decides to take one layer off the top, in which case one of these layers right here would just be 2 dimensions. So that's just B times B, or B squared. And finally, letter C says that the team finds their favorite packaging arrangement, which is taking off 2 layers of blocks off the top. So what you would do is you'd take the total, B3, and take away the 2 layers of the B squared that we found in answer B. So that might have been just a little bit trickier for you. So if you didn't quite get that one, that's fine. But hopefully with all of these algebraic and numerical expressions, this was a little bit more of a push or challenge for you to try some problems found from the algebra textbook.